So now we move forward, and the topic is peritectic and peritectoid system. So what is the peritectic? In the peritectic reaction, two phases are used to produce the one different phase with reaction just the opposite of the eutectic system. So what was the eutectic system? That is just a reverse of that. You would be getting the peritectic system. Okay. So what is that mean? That mean you have a two different uh, you know basically here it is a mistake. Yeah, okay, no, we have written here wrong. Two liquid, right? So two different liquid is going to convert it into the new solid. Or you can say if you hit the solid, okay, that will be converted into a two different liquid. Okay, that is what your peritectic system means. Okay, so two different liquid of the same alloy is being cooled, then it will be having the one solid directly without going to other dusty region. Okay, and reverse of that also possible. Okay, so liquid plus gamma, okay, going to convert it into alpha. Here is the diagram. As you can see, this is taken for the example of the Ag means silver and Pp means uh, platinum, right? Okay. So Ag means silver and platinum. Okay. So when they are combined together, okay, to make other alloy, then we would be having this particular peritectic point. Okay. So as you can see, this is your peritectic reaction at this particular point. This one, right? So that two different solid will get converted into sorry, two different liquid will that will directly converted into your solid state. Okay. This is your liquidus line. This is your liquidus line. This is solidus line. Okay. This is solidus line. This is also the solidus line. So, and as you can see in this particular diagram, Ag is basically decreasing. Ag is decreasing when they're moving forward in this way. Okay. And if we talk about the PT, then it is increasing if we moving in this way. Okay. So as we move forward from left to right, then your Ag is decreasing, meaning percentage by weight percentage Ag is decreasing and PT is increasing. Okay. This is how. And what is the peritectic? Peritectoid. Its reaction is just opposite to of that. Here alpha plus beta is basically going to convert it into gamma. Okay. So in the figure above, ABC is a liquidus line, ADEC is a solidus line. You can see ABC. So it's A, then B, then C. So this particular line, this particular curve basically is a liquidus line. Okay. And ADEC. ADEC. This is a solidus line. Okay. The line DK and EF show the variation in the solubility in the alpha and beta solid solution upon cooling. A DK and EF. DK and EF. This one is E, right? This one is E and F. This line and this line, these two lines basically showing the solubility in the alpha and beta solid solution upon cooling. This is, this is the alpha solid and this is your alpha plus beta solid. Okay. So as you can see directly, they are converted into two different solids. So peritectic reaction occurs at the temperature Td. This is just a symbol. So you can see Td. Td is here. This is your Td. This is Td. This temperature is Td. Or here it is basically Tp. Tp is the best peritectoid, peritectic. So Tp is a good. Here it is written Tp, not Td. Okay. So at temperature below the Tp, the liquid phase disappears and the beta phase appears upon the completion of the transformation. As you can see here, as soon as we will just move below this temperature Tp, then we have that solid. The liquid, this is the liquid region. Liquid plus solid basically they disappear and only solid appears. Okay. And in this region, if you see this one, if you see this region, uh, this is our peritectic temperature, and as we would just come below that, so you can see at this particular point here it is solid only, right? Not here, but at this particular point, this corner, you can see this particular this corner, right? So here you are having direct solid. So could disappear. This is what it is saying here. So platinum, silver is the good example of this particular reactions. This, as I already made this was the reaction of platinum and Ag. Okay, here Ag is 100%. Okay, but Pt is platinum is 0%, and here Pt is 100% and Ag is 0. So Ag is equal to 0%. Right. And if we talk about the peritectoid reaction, it's a reaction of the two solids into the third solid. Okay. So what is the difference so in peritectoid? Two solids is going to convert it into third solid. Okay. And here what is going to happen? Here the solid, the two liquid, a liquid plus solid is actually getting converted into solid, and this is the reaction of here only get converted into two solids. You can say two solids is going to convert into one solid. Both reverse of them are possible. Okay, so here you can see the peritectoid point. This particular point, this in this particular diagram, you can see this is your peritectoid points. Okay, so this is your peritectoid reactions. And this temperature is peritectic temperature. This is the composition of, or you can say this is just temperature. Okay, and along the y-axis, you are having the temperature only. Sorry. You are having the temperature only. Okay, and this composition, and on y-axis you have the composition. As you can see here, as I have repeated many times, as x-axis you move forward, your A will decrease and B will increase. Okay, so this is our peritectoid point. This one.